All right, hello, welcome to your Unit 3 Day 5 notes on solving rational equations. So just a quick little recall, a fraction is considered undefined if the denominator is 0. So when we solve these problems, we're going to have to make sure we always check to make sure we don't get denominators of 0, because again, that would cause your expression to be undefined. So if you have a single fraction equal to a single fraction, like a over b equals c over d, you can cross multiply to come up with a new equation to solve for your missing variable. So a times d equals b times c. So looking at example 1, that's exactly what I've got. So I'm going to do some cross multiplication. So this is 4 times, y times 4y minus 1 equals 3 times 5y, which is 4y squared minus y equals 15y. Now, since this is a quadratic, I will set it equal to 0 by subtracting the 15y. Now, at this point, I'm noticing I have a GCF of 4y that I can factor out. When I set each part equal to 0, I get y equals 0 and y equals 4. Now, this is where you have to check and say, okay, will either of those cause my original problem to be undefined? When I look at y equals 0, either one of these places would cause the denominator to be equal to 0. Because again, if you look at my original problem, I know that I can't have y equals 0 because that'll cause us to go undefined. So that means I will reject y equals 0 and get y equals 4. This is what's known as an extraneous solution. It's a solution that comes up algebraically, but when I check it in the original, it actually rejects. Okay, so same idea for the next guy. I'm going to cross multiply. All right, I'm going to go ahead and FOIL. Now on both sides I have a y cubed, which means those will drop out. And then from there, I'm going to set everything equal to 0. So I'm going to add the 4y squared over. I'm going to add the 2y. And I'm going to subtract 8. Okay, now before I go any further, I actually noticed that each of those is divisible by 2. So this is y squared minus 7y plus 12. And then that factors to y minus 3, y minus 4. Which means I get two solutions, 3 and 4. Now again, go back to your original, okay? This right here tells me that y cannot equal 4 because that would cause it to go to 0. And this guy, keep in mind that's y plus 4, y minus 4, means I cannot have plus or minus 4 on the bottom. Since I got y equals 4, that rejects. That's my extraneous solution, so y equals 3 is my answer. Okay, so these are your scenarios when you use cross multiplication. Now, what if you don't have a single fraction equal to a single fraction? So something like 1, I have a fraction plus a fraction equals a fraction. This is where a different scenario is going to come about. When cross multiplication is not an option, we will turn each term into a fraction by putting it over 1. So for example, in number 2, do you guys see these little floaters? I would put those over 1 to help me. We will then find a common denominator, just like how we did with complex fractions, and change each numerator accordingly. You may need to factor denominators to do so. Once the denominator is the same, you may ignore ignore the denominator and solve the numerator. So you're going to hear me say, drop the base when the problem equates. You will then check your final answer to make sure you don't have extraneous solutions. So again, those are answers that make our fractions undefined. Okay, so looking at the first guy, everything is a fraction, so cool. So just like what we did with our complex fractions, I'm going to look at those denominators and then decide on a common denominator. So I'm thinking I'm going to use a 12x because between 3 and 4, 3 times 4 is 12, and then I need an x in there. So what that means, I'm actually going to zoom in here. What that means is I need to manipulate this so everybody has a denominator of 12x. So you need a 4, he would need a 3x, and he would need a 12. So this would leave me with 16 over 12x plus 15x over 12x equals 36 over 12x. Okay, now once your denominators are the same, we're going to ignore them. I want you to solve the numerator. So again, when the problem equates, you can drop the base. So I have 16 plus 15x equals 36. So 15x equals 20. So x equals 20/15, or 4/3, right? Because I could divide each of those by 5. Now, if you go back to your original, is that okay? Well, the only thing I'm seeing that I can't have as a denominator is 0, because that would cause those to go undefined, so x equals 4/3 is my answer. All right, so I'm going to move on to the next example. All right, so for example 2, I'm looking at those denominators and seeing an x minus 1 and x, a 1 and a 1. So that means my common denominator will be 1 of each. And obviously times 1 is not going to make a difference. So that means, if I zoom in here, this guy would need an x. This guy would need an x minus 1. He would need both, and he would need both. Now again, once you've manipulated everything, this is your green light to drop stuff. So when the problem equates, so there's an equal sign, you may drop the base. So in the numerator, I have 4x plus 3 times x minus 1 minus 3x, x minus 1, and then times 0 is just going to be 0. So let me clean this up a bit. All right, we double check that. So 4x plus 3x minus 3, because of that distribution, minus 3x squared plus 3x. See, this is why you check your work, equals 0. All right, let me combine my like terms and rearrange this. All right, so at this point I have a leading coefficient that's negative just based on how I did this. Never try to factor with a negative in front. It's a nightmare. So just multiply through by -1, and then everything will flip-flop, which is fine because it's an equation. Whatever you do to the left, you do to the right, and it's all good. Okay, now to factor and solve this, I'm going to draw my triangle. So 3 times 3 is 9. Factors of positive 9 that sum to -10 would be -9 and -1. All right, so out of the first two terms, I can pull out a 3x. Out of the next two, I can pull a -1. And that leaves me with 3x minus 1, x minus 3. Now, when I solve, by setting each part equal to 0, keep in mind this is 3x minus 1 equals 0, so 3x equals 1. So I'm getting x to be 1/3. The other one is giving me x equals 3. Okay, now this is where we, again, got to go back and check. Is that okay? Well, if I plug 3 into any of these denominators, that's not going to make a difference. plug in 1/3, that won't make a difference either. In fact, the only restrictions I'm seeing are I can't have x equals 0 because of that x, and I also can't have x equals 1. So those didn't come up, so these are your two solutions. All right, moving on to example 3. Okay, now I'm noticing that this is a y plus 3, y minus 3 in the denominator. So when I figure out my common denominator, I'm going to use y plus 3, y minus 3, because that's one of everything I'm seeing, and manipulate as I go. All right, so this first guy is going to need a y minus 3. This guy's going to need a y plus 3, and the 18 has the common denominator, so he's good. When the problem equates, you can drop the base and solve the numerator. All right, so this is y squared minus 3y plus y squared plus 3y equals 18. 3y's would drop out, and I'm left with 2y squared equals 18. Now here I'm actually going to choose to divide by 2, and that leaves me with y squared equals 9, which means I'm getting two solutions, y is equal to plus or minus 3. Now, if you go back to your original equation, look at that denominator. I'm seeing that I cannot have y equals negative 3 because that would go undefined. And I also can't have positive 3 because that would go undefined. Either one of those would do the same thing there for a y squared minus 9. So if both of my solutions reject, that means this technically has no solution. And these were both extraneous roots. All right, so doing the exact same thing for number 4. I'm going to factor so I see what everything's made of. That's dots. Okay, so then that means this first fraction is x minus 6, or that's what he would need, because my common denominator would be one of everything. I should write that down. My common denominator is x minus 6, x plus 6. The second fraction has the common denominator, and the last one needs an x plus 6. When the problem equates, you can drop the base and solve the numerator. All right, so that leaves me with x squared minus 6x plus 16 equals x plus 6. All right, set it equal to 0, and I get x squared minus 7x plus 10. Factors of 10 that sum to negative 7 would be negative 5 and negative 2. So I'm getting x equals 5 and x equals 2 as my solutions. Now again, go back to your original. Look at that denominator. The only restrictions I'm seeing are I cannot have plus or minus 6 because that would cause my denominators to go to 0, and neither of those came up. So x equals 5 and x equals 2 are my solutions. All right, looking at number 5. This guy factors to x minus 6, x minus 2. And honestly, if you look at the rest of the problem, that kind of makes sense. Like if you're ever stuck, just look at the rest of the problem for like a hint on how to factor stuff, because likely there's some repetition there. Okay, so that means my common denominator is going to be x minus 6, x minus 2. So that means this first fraction is going to need an x minus 2. This second fraction is going to need an x minus 6. So every time I'm doing this, I'm technically multiplying the top and bottom, just so that you guys are aware, but I'm really just manipulating the numerator to solve. All right, when the problem equates, I can drop the base. I'm going to zoom in here. So 1 times x minus 2 is just x minus 2, plus x times x minus 6 equals 4. All right, let me do some rearranging. Join my x's together. Add the 4 over, so that would be plus 2. I might have made a mistake. Yep, I 100% did. This number's wrong. I'd be subtracting 4, right? So negative 2 minus 4 is a negative 6. All right, that looks a lot better. All right, so factors of negative 6 that sum to a negative 5. Using my AM factoring, thinking negative 6 and 1 would work. Okay, so I'm getting x equals 6 and x equals negative 1. Okay. Now, I got my solutions. Go back to the original. Look at this denominator. Is anything going to go undefined? Like, I'm looking at that 6 and thinking, if I plug him in right here, in that first fraction, I'm going to get 0. So that means I have to reject the x equals 6. X equals 1 is good, equals negative 1 is good. That's not going to cause any denominators to go to 0. So therefore, x equals negative 1 is your solution. All right, number 6. Okay, I'm going to take one of everybody here. Okay, so that means that the first fraction is going to need a 6x plus 2. Second one is going to need a 6x plus 3. And the last one is going to need x plus 2, x plus 3. So again, when the problem equates, drop the base. I'm going to move this over. I got a space. And then equals 17x plus 2x plus 3. Okay. For sake of time, I just wanted to at least set that one up with you all. You would have to foil these together, foil these together, foil these together, do some combining, etc., and solve for x. If you ever want to check out the solution number 6 on there, it's on our Google Classroom page. But I typically skip that problem, but I wanted to at least get you started. All right, last one I want to do is actually from a Regents. And it's question 7. All right, to solve that equation, run multiply both sides by the least common denominator. Which statement is true? 2 is an extraneous solution, 7/2 is extraneous, 0 and 2 are extraneous, and this equation does not contain any extraneous solutions. All right, in order to even find out what an extraneous solution is, you're going to have to actually solve. So when I look at this problem, I notice that this denominator is x times x minus 2. If I were to factor it. Okay, so with that being said, my common denominator would be an x and an x minus 2, because then every denominator would have one of everybody. So that means that this guy needs an x, this guy needs an x minus 2, and the 8 already has the common denominator. So if I come over here, I would rewrite this as 2x squared minus 11 times x minus 2 equals 8. Clean that up. Oops, that should be a 14. All right, so let's try to factor this. So I'm looking for factors of 28 that sum to negative 11. So negative 7 and negative 4 would work. First two terms I can pull out a 2x. Oh, I'm sorry. First two terms I can pull out an x. Next two terms I pull out a negative 2. Which means this factors to x minus 2, 2x minus 7. Which means we get roots of 2 and 7/2. Now again, go back to the original equation. If I look at that denominator, I'm seeing two restrictions. I'm seeing I cannot have 0 or 2. 0 would cause that to go undefined. 2 would cause that to go undefined, and either one would cause this to go undefined. Now, when I look at my answers, I cannot have a solution of 2, so that means this is your extraneous solution, and that's your actual solution. So when you look at your multiple choice answers, the correct one is 2 is an extraneous solution. Now, probably the biggest distractor answer is 3, because students will look for a shortcut and be like, oh, well, 0 and 2 would cause the denominators to go to 0, so that must be it. Okay? Those are just your restrictions to be aware of for the problem. Those aren't solutions. So for example, 2, while it causes everything to be undefined, or excuse me, 0, while it causes everything to be undefined, is not an actual solution. It's a restriction on the domain, but it was never a solution, so therefore it can't be an extraneous solution. All right, so that concludes our day 5 notes on rational expressions and equations. This will be on Google Classroom, so if you ever want to rewatch it or compare it with the notes that we have on Google Classroom, it'll be available for you. Your homework is then homework 5. Keep in mind, all the answers are on the back.